Hello and welcome to my tutorial for creating your own three-dimensional distance calculator in Google Sheets. So in this video obviously that's what I'm going to do. So I'm going to start in my Google Drive and go to New, Google Sheets. So this creates a blank spreadsheet for me, and I'm going to walk you through the process of going through the logic of how we're going to make this distance calculator and then do the actual building of the thing. So I'm going to name this Tour Example. So now a spreadsheet isn't magic. You're not going to just throw in a couple of numbers and it's going to tell you what you want to know. You've got to figure out for yourself how to make it do that. So part of the scientific or mathematic process, or at least you're going to use it a ton in physics, is figuring out what you know, what you don't know, and what you want to know. So for this distance calculator, we know a couple of things. We know two x coordinates in terms of, well, we will know two x coordinates. One for the first thing, we're given 2 points, point 1 and point 2. We're going to be trying to find the distance between them. So that implies we know where they are, so we know their coordinates. And what we want to find is the distance. So part of the mathematic process is figuring out how to get from what we know to what we don't know. So in this case, we know from what we know from my last video, the Pythagorean theorem in 3 dimensions, is that we know that a squared plus b squared plus c squared equals d squared. So this will allow us to, so by extension we know that d is going to be the square root of all of this stuff in here, but that isn't very helpful to us yet because we don't know how to solve for a, b, or c, because remember, these are distances, with a being the distance between the x coordinates, b being the distance between the y coordinates, and c being the distance between the z coordinates. I hope I said that right. So I'm going to grab this and move this down here. Hope it works. There we go. A, B, and C. So now we need to know, so we basically know everything here. We know how to find what we want, but we don't know how to find what we need to find what we want. I hope I said that right as well. So a here is going to be the length of one leg. If you've watched my previous video, I used the analogy of A and B being kind of these shadows of the legs of a right triangle, connecting 2 points when projected onto the xy plane, and C is just the distance between that projection and the points. So yeah, so these numbers actually have these A, B, and C actually have special names in math, being delta x, delta y, and delta z. Delta being, I think it's a Greek letter. It looks like a triangle, but it means change in. So change in x, change in y, change in z, which is kind of what the legs of a triangle are. So delta x is going to be x1 minus, it's going to be x2 minus x1 in this case. So delta x is going to be the length of a line segment between these two x coordinates. So it can be positive or negative based on which one is bigger, but as we can see in this formula here, since it's squared, that negative sign is going to go away, so we don't have to worry about that. So we now know everything, it appears. So there we go. So that is how we get everything. So now let's get on actually constructing a Google Sheets to calculate this. So I'm just going to give us a little bit of space to put our input. Input here. X coordinate. Y coordinate. Z coordinate. And you don't have to set yours up exactly like this. So 0.1, 0.2. Alright, so I'm just going to highlight all these and give them a little bit of a border so they're easier to see. Nice thick border, nice thick black border, just so it's really easy to see. So, you know, you're just going to put a couple numbers here, easy numbers. Alright, so now so basically what we want is we want to just type these numbers in and let the spreadsheet do its magic. Now, so we can see the spreadsheet work its magic, let's add a column here for the different deltas. So this first one is delta x. So whenever you want to put in a formula into Google Sheets, you do the equals, and in this case you can select specific cells. So C11, so it is column C, row 11, minus B11, so column B, cell 11. And you can manually type these yourself, but it's just really convenient to be able to click things like this. I'm going to hit enter, and it looks like it works. So I'm just going to throw in a couple of numbers here to see if I get the expected results. So notice that the deltas can be negative. So that means you'd have to travel, since this is measuring how much you'd have to move from point 1 to get to point 2. So in this case, you would have to travel 4 backwards, since we have a negative distance here. So we could actually manually type this for each and every one of these cells, but there's actually an easier way to do that, which I will show in a second here. So rather than do it this way, we can select this cell and hover our cursor over the lower right corner until we get this kind of crosshairs symbol. Click and drag it down, and that copies the formula with the exception that it has the rows increased by 1. So that should be giving us the right numbers here. Looks like it. Alright. So now we just need to add a last column where we are going to put the distance. So in this case, we know from this we can just take the square root of each side of the equation and find that d is equal to the square root of a squared plus b squared plus c squared. We are using our deltas as a, b, and c. So I'm going to do equals and then sqrt, which is the square root function. So you don't have the fancy square root symbol here. I mean, I'm not seeing it on my keyboard anywhere. So there's also no exponent. Can you do exponents? I don't think so. No, it doesn't look like you can. So in order to do exponents, you need to use the power function, or pow, as it goes. So, you know, because it's so much work to type in that last ER. So we're going to select the delta x and raise it to the 2 power. Notice how we have a comma separating the two of them. The space here is optional. Plus pow delta y 2. So that gives us delta y squared plus pow. Here's delta z. Oh, yeah, so that is one of the problems with this. So occasionally it will bug out like that. Aha, because I've missed a parenthesis. So we'll just enter it manually here. D13 is correct. And I'm gotta close out my last parenthesis here and hit enter. So we get this nasty number, which I don't want to confirm for myself whether it's correct or not. So let's see if it works with this. Yep, 3. So very useful very useful thing to remember is 2, 2, and 1 when you plug those in as the legs of a triangle in this 3D distance formula. The distance is going to be 3. So it looks like it does indeed work. So I am going to get rid of all this stuff here. So I'm going to delete the cells, shift up. I hope this doesn't break everything. Yep, looks like everything works, and these ranges automatically updated themselves. So now you have your very own distance calculator. You can format it however you want. If you don't like seeing negative numbers here, you could wrap it all in the absolute value function. And let's just do the crosshairs strategy here. And there we go. So that won't mess with this formula because we're squaring them anyway. So that gets rid of any negative signs. So that, I do believe, is it for making your own distance calculator. I hope this video was clear enough. I kind of fumbled over it in places. So good luck making your own distance calculator, and I hope you enjoy it.